All right, the first one is a complex fraction. And when I do a complex fraction, at least one method that I would probably rather use is rewrite it this way. 1 over 3q minus 2 over 5q divided by 1 over 4q plus 1 over q. Now, I'm like, wait, what happened here? Well, I saw that these threes just canceled, so let's just cancel them now and make it easier. So as long as that's okay with you, I just made that last fraction there a little simpler. So the first one, I need to get them in terms of the common denominator. And the common denominator for 3 and 5 is 15, and we already got the q. So I'm going to multiply this, and I'll maybe use a different color here to help you out. This is a times 5 times 5 times 3 times 3. So if I just rewrote this one, the bottom is going to be a 3q times 5 and a 3 times 5q, which is 15q. And on top, I have 5 minus 6, which is negative 1. Divided by, and this second one, I got a 4q and a q, so I can simply multiply the second one by a 4 over 4. And so my denominator is going to be 4q, and I have 1 plus 4, which is 5. Now remember, division is you just multiply by the reciprocal. So I have negative 1 over 15q times 4q over 5. The q's will cancel, and negative 1 times 4 is negative 4, and 15 times 5 is 75. Now, I do have to have a restriction on this. Q cannot equal, well, when I go back and look at all of these, Q being a 0 in the denominator would be a problem, so Q cannot equal 0. If you want a makeup problem for this, let's put x's in there, that's easier. 1 over 4x minus 2 over 3x, all divided by about 1 over 5x plus 4 over 2x. You can do a little division on that as well. Question number 10. Question number 10, I'm going to try to simplify as I go. This first fraction is already simplified. There's not too much I can do to simplify it, so I'm just going to rewrite it. So I'm going to have x squared over x plus 5 times. The second one I can factor. I'm looking for two numbers that multiply together and give me negative 15, add together and give me 2. I believe that's going to be x plus 5 and x minus 3. And then in the denominator, I have an x in both of these, so I'll take the x out, and I have x minus 3. There's lots of stuff that I can do to cancel things. I see that there's a x plus 5 and an x plus 5, an x minus 3 and an x minus 3, and an x to the first and an x to the second, which just leaves me x to the first. So all I'm left with really is x on top. Now I do have some restrictions because of all these denominators. So x cannot equal negative 5, x cannot equal 0, and x cannot equal 3. Doesn't matter what order you put those restrictions in. I just put them in the order I came to them, but you could go in any order you wanted. Question 11, very similar. However, in this case, because it's subtraction, it's a little bit more difficult. So we're going to see if we can factor. Unfortunately, the 3 over a plus 1 won't factor, but I can factor this top and bottom here of this. So looking for two numbers that multiply together and give me negative 56, add together and give me positive 1. That's a plus 8 and a minus 7, I believe. Over here, two numbers that multiply together give me negative 7, add together and give me negative 6. How about a minus 7 and a plus 1? Really, that makes things really nice because those a minus 7s actually cancel out. And then I already have a common denominator. The common denominator is a plus 1. So when I get my final answer, a plus 1 is going to be the denominator. In the top, I have a plus 8 minus 3, which of course, written a little bit better, becomes a plus 5 over a plus 1. If I go back to the original fractions, though, I still have to make sure that 0 is not in the denominator, including the ones I canceled. So a does not equal 7, and a does not equal negative 1. So you also need those restrictions.